Well, it's a happy Wednesday. Hope you all are having a relaxing morning, but I'm going to try and go through this quickly and just kind of give you, we need to finish up ionic bonding. We're a little bit behind, so we need to use today just to kind of do that. Now, yesterday in class, we went through and talked about naming ionic compounds. We never got to do any practice, so I kind of want to quickly kind of go over this too. So you're going to name the cation. Let's do that. Let's name the cation first. That's your positive ion. You always want to be positive first, and then you're going to name the anion last. Now, this is going to be the trickiest part of all for ionic compound. If the metal is a transition metal, actually it can be a transition metal or one of the elements way down like tin, lead, antimony, bismuth, the non-metals that are below the zigzag line. Those also have more than one possible oxidation state. So we're going to have to be able to figure out what that oxidation state is and include the name and Roman numerals in the name. Okay, and that's what we really need to practice today. Okay, so we're going to name the positive ion first, and the positive ion is just going to be the name of the metal. So sodium, NaCl is just sodium chloride. Magnesium, calcium. So you don't change, the ion is the same as the element name. There's only one polyatomic cation, and I gave that sheet to you with your ions, and that's ammonium, NH4+. And you just need to be able to recognize that NH4+ is a positive ion, that it's a cation. It's a polyatomic ion. It's all acts together as one thing. Okay? But the anions have three different suffixes. Okay? If it's a monatomic anion, it's going to end in "ide." Okay? So chlorine is the element. When you put a charge on it, Cl-, it becomes chloride. Sulfur is the element. When you put the charge on it, a 2- charge, it's sulfide. And so anions that are just one type of atom always end in "ide." But many of the polyatomic ions is a nonmetal plus some oxygens. They're going to end in either ide or ate. So I know if it's ide or ate, it's going to have some oxygens in it. It's going to be a nonmetal plus an oxygen. So if we look here at these, okay, I know that SO3 2-, that this is going to be an ite or an ate because it has a nonmetal and oxygen, and it's a charge. Notice it has a charge. If it's going to be an ion, the charge has to be written, because that's the definition of an ion, is a charged particle. So we call this one sulfite. Now, SO4 2- is called sulfate. The ate, well, I'm going to say it this way, the ite is always just one less oxygen than the ate. There's no rhyme nor reason. There really is, but you don't need to know it. As far as how many oxygens are going to be on the ate. Notice sulfate is 4, but nitrate only has 3 oxygens. Phosphate has 4. Chlorate has 3. So you just have to know the ate, but if you know what the ate is, that means that you know that the ite is always just one less oxygen. Sulfates SO4 2-, so sulfites SO3 2-. Nitrates NO3-, so nitrites NO2-. Everything's the same charge, we just have one less oxygen. But all compounds end in either ide, ite, or ate. Okay? Now, we also talked about what if we have more than 2? We only have 2 suffixes. We have chlorate and we have chlorite. But if you have one less than the chlorite, ClO, then we use the prefix hypo, meaning below. Below, one less oxygen, below. Or the prefix for chlorate was one above, it's hyper, but we take the high off and just call it perchlorate because it's going to have one more oxygen. Now, all of the halogens are going to do this. Okay? All of the halogens. So, if I did BrO3-, that's going to be bromate. If I do IO3-, that's going to be iodate. So IO- is hypoiodite. IO2- would be iodite. So BrO2 minus would be bromite. So by knowing one, you can really know them all. If you understand the fact that ites are always one less than the eights, you know hypo is below the ite, hyper is above the 8, you can know all of those by knowing one. So I always say focus on knowing the 8s. They're the most common anyway. Know the 8s, the chlorate, the sulfate, the nitrate. You know the ite will always be one less oxygen. Then halogens really are the only ones that do this hypo and per. There is another ion, permanganate, MnO4 minus, but I've never seen just manganate or manganite. I've never seen MnO3 or MnO2. Okay, so but it is permanganate. So per is used in other things, but the halogens by far are the most common. Okay, so we're going to name the positive ion first, the negative ion last. The negative ion is either going to end in ide, or ate. And then the tricky part is going to be if the metal is a transition metal with more than one oxidation state. Now the way you're going to know that is you're going to get your periodic table out, the color periodic table that I gave to you, and you're going to just look at the symbol, and if there's more than one, a number above the symbol, that means yes, it has more than one oxidation state. So let's look at these practice right here and just kind of go through these and how we're going to name them. Okay, so if I'm looking here, I know that that is sodium. So I'm going to name the positive ion first, sodium. Now, this is just chlorine, there's no oxygen with it, so it's going to end in ide, so it's going to be sodium chloride. Now, calcium, all by itself. There's no oxygen with this, so it's just going to be fluoride. So the positive is just the name of the element. And you'll always have a periodic table. And by the way, when you spell fluoride, notice that it's UO, not OU. If you spell it FLOUR, that's flour, like you bake with. Okay, so fluoride is FLUORID. So now when I'm looking at this one, but now I have to realize there's always a positive thing and a negative thing. This is my positive thing. This whole thing is my negative thing. So I don't try and name it phosphorus and oxygen and all that. I have to recognize that PO4 is the phosphate ion. That's the polyatomic ion. You have to look on your sheet. You have to be able to recognize. You always have one positive thing, one negative thing. No matter how complicated the molecule is, one positive, one negative. The negative will generally be your polyatomic ion. So we're going to say calcium again. Now notice I am not using, and I'm going to say calcium phosphate. I'm just going to name my ions. Notice I don't have to worry about the 3 and the 2 at all, because there's only calcium can only be one charge. Calcium can only be +2. And again, you should know this from previous units, but all your alkaline metals are going to be +1. All your alkaline earth metals, group 2, are going to be +2. That's the only possible charge that they can have. Phosphate is always -3, so there's only one way they can come together. So we don't have to use prefixes, subscript, we don't have to say anything about how many there are. Just name the positive ion first, the negative ion last. Okay? But now when I go and look at this one, Fe, iron is a transition metal. It's the number 26 on the periodic table. It's right there in the middle, and if you look above the iron, you'll see that it has the possibilities of 3, 2, and 6. That means there are 3 potential oxidation states. So I can't just be a psychic and just say iron chloride and know which one it is. So you have to figure out what is the charge on this one. And to do that, you have to use the charge on the other one. I know chloride halogens are always -1. I have 2 of them, so it's -2. Some of the oxidation numbers in a compound always have to add up to 0. Therefore, iron must be in the +2 oxidation state. Because I have to get, -1 times 2 is a -2, so I have to balance that out with a +2. So I'm going to have to say it's iron 2 chloride. This Roman numeral right here tells me the charge on the iron. It's not how many of them you have, it's the charge on them. Okay, so when the metal, and the only way to know if this has more than one is to look on the periodic table. That's why I give it to you. So you got to take time. You don't just guess whether it has more than one or not, because some of the transition metals only have one, so you would not use a Roman numeral for those. Okay? So now when I come up over here to this one, again it's iron, but this time it's FeCl3. Okay? So I know chlorine is -1. I have 3 of them, -3. It has to add up to 0 because the charges always add up to 0. Therefore, since there's only one iron, the charge must be +3. So hopefully you're thinking through what the name would be. Because it's the positive ion is a metal with more than one oxidation state, I have to include Roman numerals. So I'll say iron 3 chloride. Again, the 3 tells me the charge on the iron. The next one, Cu2O. Again, copper is a transition metal. You look on the periodic table, copper is a transition metal. You look above the symbol, you can see it can be 2 or a 1. So I have to be able to determine, is it copper is in the +1 state, or is it in the +2 state? To do that, I look at what it's attached to. Oxygen. Well, oxygen is always -2. Therefore, my total positive is +2, but I have 2 of them, which means each one must be +1. So when I say the name, I'm going to say copper 1 oxide. Whereas on this one, oxygen's -2, copper must be +2 then. So this is going to be copper 2 oxide. Now I like this example because it highlights the fact that the Roman numeral tells you the charge, not the subscript. It's always what's the charge on the metal. Roman numerals only go to the positive, it only goes to transition metals. And you never have a Roman numeral on the negative one. It's always just going to be what's the charge on the positive ion. So when we're naming these, we're just going to name the positive ion first, the negative ion last. Now again, if it's just monatomic, it's going to end in I, whatever the element is. So if it even one that you've never seen before, Te, tellurium, you know it'd be telluride. Okay, it's a cool name. They named a ski resort after it. Okay, if it's bromine, you know it's going to be bromide. So you just put I. If it's a polyatomic ion, it's going to end in ite or ate. Now there are 2 exceptions to that, and I think it's in the notes, the 2 exceptions. But you just need to know these. OH minus is equal to hydroxide. That's the hydroxide ion. Now that's on the sheet, okay? You don't have to memorize it, but it is a polyatomic ion that does not end in ite or ate. And the other one is Cn minus, which is cyanide. Those are the only 2, oh Lord, I misspelled this. Hydroxide, sorry. Okay, cyanide and hydroxide. Those 2 ions are polyatomic, but they don't end in ate or ite. They're just unique. So there's 3 unique ones you need to know. Ammonium, NH4+. That's the only polyatomic cation, the only polyatomic positive ion. So these 3 are just ones you just need to be able to recognize. All the other ones kind of stand out and will be on that. All of these are on this sheet that I gave to you, but these kind of are a little bit different than all the rest of them. Okay? So for naming them, all we do, positive first, negative last, we just have to check, is the metal a transition metal with more than one oxidation state? If yes, we have to figure out what the charge is and include it in the name in Roman numerals. That's the hardest part. I'm going to let you practice some of those this afternoon, and then we'll talk about them in class on Thursday. All right, so what about writing formulas? It's just going to be the reverse. It's the same principle. It's just we have to know the oxidation numbers all have to add up to 0. So, when I'm writing formulas, just like in the name, we're always going to be positive. Positive ion first, negative ion last. Okay? Now, this is going to be the important part here. Balance the charge using, well, we're going to call it crisscross method. Okay? Okay? Positive charge must equal negative charge, yielding the sum of zero. Again, compounds, the charges always add up to zero. Now, if the positive ion is a transition metal with more than one oxidation state, the charge is going to be given with Roman numerals. Just like we had to do when we were naming it with the Roman numerals. The Roman numeral given is the charge of the metal, not how many there are. Okay? So this crisscross method is just, all we're doing is finding the lowest common multiple. What's the lowest number that both of the charges go into? Most of the time it's pretty straightforward, pretty simple. Okay? Let's just look at some practice ones. If we just look at these. Barium and chloride. So you just write the symbol and charge for each one. Barium's +2, chloride's -1. Well, I have to make those charges equal to 0. Well, that means if I have a +2 and a -1, I need 2 of these things. Because then I'll have -2 and I'll have +2, and it's going to equal 0. Okay? Let me make that a little bit bigger. It might be a little bit easier to see. So +2 and -1, and so I'm going to say the formula is BaCl2, because I need 2 chlorides to balance out the 1 barium, because I need to make the sum of the charges equal to 0. That's what we're talking about crisscross. So we have the +1 here, we have a -2 here. Again, I'm going to need 2 of these so I can bring this down. Notice I brought that there. We don't write ones, okay? But this is going to be a 2, because 2 times +1 is +2. We have a -2. It's going to equal 0. So my formula is going to be Na2O. Now, magnesium sulfide. Magnesium sulfide. So you go and you look on the periodic table. Magnesium's in the second column. It's an alkaline earth metal. They always have a charge of 2+. Okay, now don't worry about when the sign is in front and the sign in the back. The technical reason for that is if it's in the front, it represents the oxidation state, which is really more important for covalent bonding than ionic. If the sign's afterwards, that means it's the actual charge on an ion. Since these are all ions, we put the charge afterwards. But for all these ions, the oxidation state and the charge are exactly the same. So it's really kind of, you'll never lose points whether you put the sign in front or back. There's a slight difference. It's not that big of a deal. So magnesium sulfide. Now sulfide is in the oxygen family, the chalcogens, and so those all have a -2 charge. So 2+, it already equals 0. So we're going to use the simplest ratio. We're not going to say 2 and 2. We're going to use the simplest ratio for ionic compounds, the empirical formula. So it's just going to be MgS. We don't need, if it ain't broke, don't fix it. Same thing here. Now notice here that we have a Roman numeral. It's much easier going this way because the Roman numeral, I don't even have to look on the periodic table now. Now I know the charge on the iron is +3. So it's going to be Fe, 3+, and then oxide is oxygen, it's always 2-. This is where the crisscross method really is important, because what's the lowest number that 3 and 2 both go into? Well, obviously it's 6. Well, the way you get that is cross multiplying. So you bring this one down here, make a 2. You bring this one here with a 3. So then it's 2 times +3 is +6. 3 times 2 minus is -6. It all adds up to 0. So my formula is Fe2O3. Okay? Now, when you have a polyatomic ion that you need more than one of, okay, so this is your +2, I need to bring this 2, but I need 2 of the whole thing, so I have to put it in parentheses with the subscript 2. Only when you have more than one polyatomic ion. Notice there's no parentheses on any of these, because they're all monatomic ions. You only need a parenthesis when you have more than one polyatomic ion. So if we're looking at this one, ammonium phosphate, NH4+, that's that one I told you just have to know, ammonium, that's the only positive one. Phosphate, you look on your chart and you see that it's PO4, 3-. Well, since it's +1 and -3, I need to bring that 3 down here. I need to crisscross, but I need 3, not just H's, I need 3 NH4s. So I'm going to have to put a parentheses, NH4, 3, PO4. So to write the formulas, we just have to make sure the charges balance, and we do that using subscripts. And so you just make sure you just do the crisscross method. Now, it's always got to be reduced, so even if it was a +2 and a +4, or a -4, it would be 2 and 4, but you reduce that to 1 and 2. These ionic compounds always use the empirical formula, the simplest ratio. Okay? Now, on Thursday, we'll go over these. I'm going to give you some practice to do. We'll go over these. Molecular compounds are the easiest of all. I can explain how to do those in 5 minutes. Okay, I'll do that on Thursday. And then the only other thing we have to do is name acids and write formulas for acids. And that's not as challenging even as the ionic. So today, I just want you to practice doing some of these ionics. We're going to write some formulas and we're going to name. And then we'll do the other two. Hopefully I'll get both of them done on Thursday in class. We can practice all on Friday, and then we can have some kind of comprehension survey next week at some point. All right, I hope you have a great day, and go Jags.